In this session, we are going to discuss about atoms. See, atom we know it's the smallest building block. Atom is nothing but the smallest building block, right? So here we are going to discuss about the Bohr model, the energy of electron. What is the electron in each orbit? That all. What is in each orbit? How many electrons we can accommodate? These all we will discuss in this session. Now you see, we all know that atom consists of a nucleus. Around the nucleus, we have the electrons. Electrons are revolving around the nucleus. Now this is your nucleus and these are electrons revolving around nucleus. Now, the radius of each orbit we can calculate by an equation. The radius of the nth orbit is r naught n square divided by z. This is the equation to find the radius of the nth orbit. Even we can find the velocity as 2.2 into 10 to the power of 6 z by n is the equation for velocity. And even the energy of an electron in the nth orbit, I can write minus 13.6 z square by n square electron volt. This is the equation for energy of electron in an nth orbit. So as the n value is getting increased, the energy value is getting increased. So when an electron is jumped from the lower level to higher level, the energy is required for that process. But when the electron is jumping from higher to lower level, the energy is liberated in the form of photons. So most questions are based on these equations. So you always remember this. This is the total energy. And even we know that the kinetic energy is the positive of this one. Potential energy is twice as that of total energy. Like that we have many other relations also. So first I am going to discuss some few numericals based on this. Now in our material we have the page number 65, question number, page number 65, the question number 8, page number 265, question number 8. They are given here the energy to remove the electron from a singly ionized helium is 2.2 times the energy required to remove an electron from helium atom. The total energy required to ionize the helium atom completely is. So here they are asking, we should find what is the energy required to remove the total electrons of helium atom. But they gave the case, the energy required to remove electron from singly ionized helium. Singly ionized helium is equal to 2.2 times the energy required to remove electron from a helium atom. See the question I have written because there is both are helium. People will get confused. This is the singly ionized helium and this is your normal helium only. So singly ionized helium is nothing but it is same like your hydrogen atom. So in those cases, I can use the equation. Here I have written an equation for energy. This is the energy of an electron in this orbit. If the electron wants to come out from that orbit, you have to provide the positive energy of this. Now, see here they are talking about the simply ionized helium and what is the energy here. So I can write the equation for a helium atom, for a singly ionized helium, I'm just writing here, singly ionized Singly ionized helium, for a singly ionized helium, the energy I can write it as 13.6 into 2 square by n is 1, that is 13.6 into 4. 13.6 into 4 is nothing but 54.4 electron volt is the energy required to remove an electron from a singly ionized helium. And they are given, this E1 is nothing but 2.2 times of the energy required to remove from the helium atom. I can write this as 54.4 is equal to 2.2 E. So what is E here? 54.4 divided by 2.2. That is nothing but 24.73 electron volts. Now, we got two cases now. The question is, what is the energy required to remove, remove the total electrons of helium. The total electrons of helium. How many electrons are there for helium? 2. So, when one is going, it becomes this energy. When one electron is going, it goes as a singly ionized helium. So the total energy required, I can write 54.4 plus 24.73, that is nothing but 79.13 electron volts. So you see, I need to repeat it. We are talking about the energy of a helium electron. Energy of a helium atom. We have helium, singly ionized helium. Singly ionized helium means one electron is gone. So if one electron is gone means singly ionized helium resembles same like a hydrogen atom. So I can use the same equation to find the energy. So first I did singly ionized helium. The energy E1 is 54.4 electron volt. Now I can take E1. E1 equals 2.2 E. I can take this as 54.4 is equal to 2.2 E. This they are given in the question. Here only one thing you remember, two helium they are mentioning. One is singly ionized helium, other one is our normal helium atom. When a normal helium atom, one electron loss, that become equal to singly ionized helium. Then again one more electron is going, means total electron is lost from here. Okay? Next. Next is page number 266. Question number 15. This actually is a simple question. We know according to Bohr model, all electrons are revolving around the nucleus in particular circular orbit or stationary orbits. And the second one, we are talking about the law of conservation of momentum. When an electron revolving in a circular orbit, its angular momentum should be the multiple of nh by 2 pi. Third law tells that when an electron jumps from higher level to a lower level, the energy will be emitted in the form of photons. So the question they are given like this. This is the value they are given. Lambda 1 and lambda 2 are emitted like this. We should find what is lambda 1 by lambda 2. What is lambda 1 by lambda 2? How we will do this? I can do it like this. First, we should take here what is the energy. So I'm just taking here, when an electron is jumping from lambda, we know lambda is equal to h by, or E is equal to h mu. Mu is nothing but c by lambda. So lambda I can write hc by E, or lambda is inversely proportional to the difference in energy. So I can write the lambda 1 is nothing but, it is due to the difference of which energies lambda 1 is minus E minus of minus 2E. That is nothing but 1 by E. Lambda 2 I can write 1 by minus E minus of minus 4 by 3E. That is, I can just take the case that is 1 by minus C plus 4 by 3E. That is 1 by 3 is LCM, that is E by 3. 3 plus 1, I can write it as E by 3. So we need to find what is lambda 1 by lambda 2. That is 1 by E by 1 by E by 3. So this will go up, that is nothing but 3. So we get an answer here. We get an answer here as 1 by 3. Lambda 1 by lambda 2 as 1 by 3. E by 3, 1 by E, so it is 1 by 3. So I can write here lambda 1 by lambda 2 is nothing but 1 by 3. So this is simple only. We are using Bohr postulate. According to Bohr postulate, when an electron jumps from higher level to lower level, it will emit the energy in the form of photons. So I can write here lambda 1 by lambda 2 is 1 by 3. Next. Next question. Page number 266. Question number 90. According to Bohr theory, the time average magnetic field at center of a hydrogen atom due to the motion of electrons in the nth orbit is. It means we know the electrons are revolving around the nucleus. Due to this revolution, okay, we don't know which orbit it is. I've taken simply like this. So I should find what is the magnetic field at center. When an electron is moving in a circular path, even the circular current will produce. So I can take here the equation is nothing but mu naught I by 2r, magnetic field at center. B is nothing but magnetic field. So I can take the magnetic field B equals mu naught I by 2r. That is mu naught by 2 into r into I can write it as E by T. Again I can rewrite as mu naught by 2r into E by 2 pi r into V. V will go up. So this equation I can write 2E mu naught by 4 pi into equation will come as V by r square. Here you should remember the important thing. We know that the radius is proportional to n square and the velocity is inversely proportional to n. So if I write it a proportionality sign, because these all are constants, I can write this as 1 by n square the whole square. That is proportional to 1 n power 5, or It is proportional to n power minus 5. And this proportionality is very, very important. We know that it's not only proportional to n square, even z also it's important only. So we should write r proportional to n square. Next. Next question. Question number 22. Question number 22. It's page number 267. Question number 22. Page number 267. Question number 22. The